Going to discuss the AC series and parallel circuits. It will be utilizing the concept of DC circuit analysis as well, and it will also be using the phasors, which is the backbone to facilitate or to carry out the analysis of AC circuits. So as the name suggests that we will be dealing with the sinusoidal sources. So the phasor is having the unique advantages that while say dealing with that sinusoidal time varying quantities, the reference of time and the frequency is not coming in the phasor analysis. So the calculations are greatly simplified. The various mathematical operations can be done with the phasors. However, the important which is to be used frequently, it is the derivative of a phasor and the integral of a phasor. So the derivative of a phasor is equivalent to the phasor getting multiplied by the j omega, where say the integral is equivalent to the original phasor getting divided by the j omega likewise. So however, the important point is that after carrying out the analysis with the phasors, we can easily write the time varying sinusoidal term for the parameters or the quantities which are of interest. So we will be going for the phasor relations for the circuit elements, that is the RLC parameters. Then we will be analyzing the AC circuit analysis, going for the parallel AC circuits. So the various combination of the circuits will be considered in this discussion. So this particular is a resistance. As a electric circuit consisting of only resistive element is represented likewise. We know the fundamental relation V is equal to IR. So here say the VR, IR, they are just to give the nomenclature that these particular voltage and currents are associated with the resistance. So this particular relationship when translated into the with the sinusoidal source, so it will be having the form like Vm upon R sine of omega t. We are considering that this particular source is of Vm sine omega t nature. Now when say we are seeing the instantaneous waveform, the voltage and the current wave shape coincides, only say there is a change in the magnitude, but the phase relationship is identical. So that particular is suggesting that IR is in phase with the VR, and this particular is also true while say we are having a phasor form of representation. The magnitude difference is decided by the resistance value and so on. For the inductance, we are having a fundamental relation VL is equal to L di by dt. So when say the current is given and we are interested in expressing the voltage in the phasor form, it will be the current phasor getting multiplied by the j omega. So that is giving you the derivative when it is multiplied by L. So the voltage expression will be j omega L multiplied by the current. For the converse relationship, if we are writing the voltage is given, so we can do it by the integration. So the integration is leading to the division of the phasor by the j omega. So that particular is the other approach. While say we are having a plotting, it is likewise. So this IL with respect to the voltage is lagging by 90 degree likewise, and that lag relationship which is presented over here is represented into the phasor diagram. So you can say the IL lags VL by 90 degree, or conversely the VL leads IL by 90 degree. So this 90 degree etc. that has been covered in the with the help of J operator as well previously. This will also be revisited as a summary. Now with the capacitance, the relationship, fundamental relationship is known to us. So that is IC is equal to C dVc by dt, or you can say Vc is equal to 1 upon C I dt. So here say the voltage is known, so current will be calculated. So this is the expression of the current. Voltage is taken as a sinusoidal reference, it is giving rise to the cosine. As a standard arrangement that we have to express all parameters into the sine form, because the sign was a reference, so it is leading to the 90 degree. So in that sense you can say that the current leads the voltage by 90 degree. Magnitude is coming out to be decided by the, you can say, passive circuit element value. On the instantaneous basis, when say we are seeing the plot of voltage and current, this particular will be the nature. So here say the current is coming out to be leading to the voltage by 90 degree, and that lag lead relationship you can easily see with respect to the time when say t is equal to taken as 0, that is a reference point, and so on. So you can say the IC leads VC by 90 degree, or you can say the VC lags IC by 90 degree. So previously we also summarized the J operator. Here it is again say the same topic is revisited. J is a 90 degree lead operator. J square is coming out to be equal to -1. So minus J is equal to nothing but it will be a 90 degree lag operator. So conversely, the voltage current relationship for the three circuit elements can be written likewise. Here say it is clearly suggesting that the IL is lagging by 90 degree to the V, where say IC is leading by 90 degree to the V. So this fundamental definitions, fundamental relationship which we developed previously will be used in analyzing the series parallel circuits. So here say the RL combination. So what we can see that there will be a KVL. So KVL suggests that the supply voltage is equal to the voltage drop across the resistance plus the voltage drop across the inductor. So that is a fundamental relationship. On the similar line, when say we can analyze it by the phasor. So what is the arrangement for the phasor? That VR is equal to I into R and VL is equal to J omega L multiplied by I. So that particular is substituted and so on. So from this particular, if suppose say the voltage is known, we can calculate the current phasor directly. So R plus J omega L, that is giving the impedance, so that is the Z angle theta. As we have mentioned that the magnitude of the phasors during the division are getting divided and the angle is subtracted. So here say the minus theta. If suppose say this voltage phasor is of 0 value, having a 0 value initially, then that particular will be V upon Z likewise. So this particular is a voltage. The current is calculated because this is a minus theta, so it is a lagging current, that particular is marked. You can easily see that the voltage across the resistance will be in line with the current, so that is the VR. When you can see that the voltage across the inductor is 90 degree leading to the current, so that particular is marked likewise. So that is completing the phasor representing the voltage and current parameters. On the impedance triangle, you can see the resistance. Here say the XL, so that particular is basically JXL is or J omega L, that is participating 90 degree leading, and so the Z is coming out to be like this. Z value will be root of R square plus XL square, and theta value from this impedance angle triangle tan inverse XL upon R, or that particular will be equal to tan inverse omega L upon R. Now the point here is, which we have to remember for all discussion, that the theta value lies between 0 and 90 degree. So that should be the point of discussion, that during the phasor analysis it is the value of phase angle is always 0 and between 0 and 90 degree. On the similar line, we have gone through the analysis for the RC circuit, series RC circuit. So this is giving rise to the phasor relationship V is equal to VR plus VC. As we know previously that VR is equal to I into R plus capacitor voltage lags the current by 90 degrees. So VC is equal to I upon J omega C, that is substituted. It is simply giving rise to here say the theta angle is coming out to be positive. So that particular suggests that the current in the RC circuit leads the supply voltage. So that particular is marked here, and on the similar line here say the voltage VR is along the direction of current, VC will be 90 degree lagging to the current, so that particular is marked. This particular phasor is depicted here just to give you the phasor sum. So the VR plus VC is giving you the supply voltage value. On the impedance triangle, we will be making use of this particular relations that say, so the resistance X is coming out to be downward, and pertaining to this the theta angle will be negative as mentioned here. So here also what we have to keep in mind that the theta value is lying between 0 and 90 degree. Now while say we can make use of the concept of series RC and RL circuits, now we can analyze the series RLC. So the fundamental relationship on the instantaneous basis is likewise. When say we are substituting the value of the elements, it is coming out to be the relation IR plus LdI by dt plus 1 upon C I dt is equal to the supply voltage. In the phasor form, this particular is substituted. This is a series circuit, current is common, so that particular is taken as a reference, and correspondingly we are substituting the VR, so that is I into R, so that is R. VL is equal to j omega L into I, so that is j omega L. VC is equal to minus j upon omega C into I likewise. So with this arrangement, for the given supply voltage we can calculate the current likewise, and that particular can be calculated. This particular is term R plus j omega L minus 1 upon omega C basically will drive the behavior. So here say it particular is represented in a general nomenclature Z angle theta. So here you please be careful, refer that the theta is written as positive. So when say theta is written positive, we are presuming that omega L is greater than 1 upon omega C. So omega L is the reactance offered by the inductor, 1 upon omega C is the reactance offered by the capacitor. So that particular are say the two relations, fundamental relations of the impedance value and the phase angle we can associate. However, the exact behavior will be decided by the nature of XL with respect to the XC. So when say XL is coming out to be greater than XC, it will be an inductive circuit and the current I will be lagging to the supply voltage. When XL is less than XC, so you can say the XC is greater than XL, the behavior will be capacitive and the I will be leading the voltage. When say both are coming out to be equal, the behavior of the circuit will be resistive. So although say the inductor and capacitors are present in the circuit, but the behavior will be resistive, and this particular is giving us an important identity which we will be utilizing in the next, that is the condition of resonance. So similar procedure is there. Here say the phasor is drawn in say the different manner because the current is coming out to be common. So we have used the current as a reference. Voltage drop across the resistance is marked along the direction of current. Voltage across the inductor which is 90 degree leading, so VL is marked. VC which is 90 degree lagging, that particular is marked. So as mentioned that the expression here is written when say we consider the XL greater than XC, so the resulting value, that is the sum of VC plus VL, will be attempted like this. So this particular is giving the value theta, or you can say the voltage V will be leading by angle theta to the current I. You can rotate it by any, so the current I will come out to be lagging by the same angle theta and so on. So this is on the similar line, we can have the impedance angle and so on. Now the steps for the analysis, if suppose say we will be utilizing this equation, express the input voltage as phasors. So depending on that general equation, we can write it into the phasor form, which is equal to V having say the angle. Then we will be computing the impedance and the theta. So depending on whether the combination is RL, RC or RLC, these particular can be calculated. Then the current will be computed likewise. So correspondingly, once the current is known, we can calculate the voltage across the resistance. We can calculate the voltage across the inductor, which is I into j omega L. We can calculate the voltage across the capacitor, I multiplied by minus j upon omega c. Thereafter, we can draw the phasor diagram. It's such. Now the beauty of the phasor diagram that it can be rotated by any arbitrary angle, but the purpose will be same. It will remain the same phasor, and it will convey also the same meaning. Now parallel RLC, that particular is a simple arrangement where say the three elements are connected in parallel. So we will be using the KCL here. I is equal to IR plus IL plus IC. This particular is written on the instantaneous basis, so corresponding the phasor expression will be like this. Now with corresponding to say you can easily see that the voltage across these elements will be identical. So once the voltage is known, the current can be calculated. So current across this resistance will be V upon R. Corresponding to the inductor, it will be V upon j omega L. So as say the j square is equal to minus 1, it is giving rise to this negative sign. Similarly, for the capacitor, the current value will be j omega c multiplied by the voltage. Now as an analogous term, 1 over resistance is equal to the conductance. So 1 over reactance is giving us the value of, you can say the susceptance, BL and say the BC likewise. So for this particular, you can easily have that when say the BL is coming out to be dominating, the behavior will be inductive. BL is greater than BC. When say BL is less than BC, the behavior will be capacitive. When BL is equal to BC, the behavior will be resistive. So the phasor diagrams are drawn likewise. Here again say you can see that the IL is coming out to be dominating, then the IC. So the net current will be the IR plus somewhere likewise, and the current value will be lagging. Now this particular is a little practical approach where say you can say the inductor is consisting of a resistance in series, or you can make use of that this is a practical coil which is always having some resistance there. So in this we will also be analyzing on the similar line, and you can easily see that the KCL suggests I is equal to I1 plus I2. However, the KVL, so the voltage across this series combination will be equal to the supply voltage. Voltage across this series RC combination will be equal to the supply voltage likewise. So in that way we have done. Now you can easily calculate the I1 is equal to V upon Z1. So that is one approach. Similarly, I2 is equal to V upon Z2. So these are, you can say the I1, I2 you can calculate the way we have calculated for series RL and series RC circuits. Now while say we are doing the summation, as mentioned previously that the sum works out to be convenient while say having a rectangular form of the representation of phasor. So these particular phasors are converted into the rectangular form and then they are added likewise. So because of this, one is having say the RL load, so it is giving the lagging current. Another particular is RC, so it is giving rise to the leading angle. So that's why this negative sign is coming out to be there. So depending on this, the overall behavior will be decided. Likewise, what will be the ultimate arrangement. Now this we have done the mathematical arrangement. However, we can easily do the concept of superposition. Basically this is the concept of superposition. So we are redrawing the phasor separately for R1L, RL branch. So in that the current is coming out to be lagging. For the RC, the current is coming out to be leading, that particular is marked. Now the superimposed there, so that particular will be the arrangement, and the net current is decided by the law of parallelogram and so on. So that particular is giving you the value. So in this particular case, it is coming out to be capacitive behavior. Now the power is also important. So what is that? With the given value of circuit elements, you can calculate the impedance. This impedance is impressed across the voltage, so it is giving rise to the current I. The power in the AC circuit is expressed as V into I conjugate. So this conjugate is also important. So how it is attempted? Because of this conjugate operation, the magnitude remains same. However, the angle associated with the phasor gets changed by the negative sign. So if let's say it is having the minus theta, with the conjugate it will come out to be the positive theta, plus theta likewise. Now this conjugate is also helping to find out the exact phase difference between the current phasor and the voltage phasor. So if let's say the voltage is having a reference of phi 1, current is coming out to be some reference of phi 1 minus theta, so the difference will be calculated as only theta. So this is giving rise to the term. This is expanded into the rectangular form of representation, so s cosine theta plus j s sin theta, and likewise you keep on expanding. So this particular P, which is the real power term, Q is the reactive power term, so that reactive power is measured in terms of the volt ampere reactive, or that is designated as VAR likewise. Now there are some facts which are related to the power factor. It is the cosine of the angle between V and I. This particular power factor value is always positive. However, depending on the nature of the voltage and current, so we have to specify the lag for the RL circuit, lead for the RC circuit. So let's say if the power factor is 0.7, then with the RL it is more precisely be specified as 0.7 lag. For the RC circuit or net capacitive behavior, it is 0.7 lead. So basically this lag lead relationship reflects the nature of the current with respect to voltage. Now take one example here where say the circuit is consuming 700 watt, having a power factor of 0.707 lead, so that particular is important, and having say the applied voltage of 141.1 sine of 314t plus 30 degree, and we have to find out the circuit elements. So please be mindful that this particular is the peak value Vm. So if you are calculating the RMS value, it is to be divided by the root 2, so that is resulting into the 100 volt likewise. So if suppose say the same question can be given that it is having say the 100 volt supply likewise. So this particular is V, known parameters you have summed up. Here say the cosine theta is 0.707 lambda. Now we will be invoking the concept of the phasor, so it is the Vi conjugate. So Vi is a phasor quantity, I will also be resulting into the phasor quantity. So the phasor, its magnitude will be P upon V cosine theta, so that is giving rise to the 10 ampere. You have done the V upon I, so that is the impedance value. It is not to be taken as resistance because it is a series AC circuit. So this particular is 10 ohm. Now this lead nature is specifying that it is a RC circuit, and so corresponding to this theta can be calculated as cosine inverse of the power factor, which is resulting into the 45 degree. We can calculate the value of resistance, reactance by the impedance triangle. Likewise, once this reactance is calculated, we can calculate the capacitance. So you please be mindful that the reactance value in capacitive circuit Xc is equal to 1 upon omega C. So C is calculated, that is giving rise to. Now we have to also write the phasor expression for individual component and also write the instantaneous form. So just as a reference that the given problem is sine of 314t plus 30 degree. So whatever say we obtained for the phasor, it will be likewise summed up. Current is coming out to be RC circuit, so leading by 45. Original voltage was given as 30 degree reference, so the new current angle will be 30 plus 45. Impedance is having say the angle corresponding to the theta. It is a RC circuit, so it is angle, its angle will be with negative sign. Similarly, the voltage across the resistance is marked, that is I into R. Vc is equal to minus J I X C. So that particular is you are able to mark. Likewise, so I is having 75 degree, minus J is contributing minus 90, so it is minus 15 degree. Correspondingly, you can write it by seeing this particular angle as, let's say, 75. So that particular is done. The voltage which is coming out to be 70, while we are writing into the instantaneous form, it is to be multiplied by root 2. The same process has to be repeated for others. So similarly, while see you are writing for the Q, you will be specifying the lag and lead arrangement the way we are specifying for the power factor. This particular is another example where say the resistance of 20 ohm, inductance, capacitance are connected in series and are fed by 230 volt supply. So the 230 volt here is the RMS value. Likewise, so correspondingly omega you can calculate, XC, XL, XC you can calculate. They are connected in series, so the net reactance you can calculate. Once say the reactance is calculated, you can calculate the impedance value, theta value. Likewise, this Z and theta are you can say coming out to be the polar form of representation. Into the rectangular form, this particular can be written as, so reciprocal of the impedance is the admittance. This particular is giving rise to the value. Likewise, the power factor is decided by the cosine of theta, so that particular is calculated as it is. Current value, magnitude, it is V upon Z. Active power, reactive power, and so on. Here say the point which is interesting, that the X, which is calculated as XL minus XC, is coming out to be positive. So the behavior of the circuit will be inductive, and correspondingly the power factor will be of lagging nature. Current will also be lagging. So now as a summary, you can easily see that the inductor current lags its voltage by 90 degree. Capacitor current leads its voltage by 90 degree. For the resistive circuit, voltage and say current is in phase with the voltage. The fundamental law holds true when applied in the phasor forms as well. Next, we will be discussing the resonance in the series AC circuits. You can refer these particular textbooks for further reference.